Okay, in 11.6 we explore a new coordinate system, which is called polar coordinates. So the coordinate system that we've been using, that you've probably used in math up until now, is the rectangular coordinate system. And that means that it's laid out in squares or rectangles. And you would graph something like 2, 4, where this is your x and this is your y, and the x tells you to go left or right, and the y tells you to go up or down. So you'd go over 2, up 4, that would be the point 2, 4. And this could all be blocked out in grids, but that's the basic idea, is that you go over the first amount and up the second amount, or left and down, positive, negative, depends. Okay, so the polar coordinate system is a different way to describe points. They're all the same points on the graph, but it's a different way to describe them using r and theta. So instead of x and y, we use r and theta, and this is the same r and theta that we've been using all along when we talked about being on the unit circle and being on other circles. So when you describe something by r and theta, let's say, for example, we look at the point 2, 45 degrees. Okay, so 2 is our radius and 45 degrees is our theta. So it's the same as, the angles are the same as what we looked at before. So 45 degrees would be along there. Okay, that's 45 degrees. And then 2, the radius 2 tells us to go out 2 units from the center. So the distance here is described in concentric circles. So we would go, let's say, out 1, out 2 units, and it would be like that. Okay, so drawing polar coordinates is a little bit more challenging than drawing rectangular coordinates, because we could just put notches on an axis for this. To see the units here is a little bit more challenging. We could make circles like this to see it, or sometimes you can put like little dashed circles like this. For what we're doing, I'm going to go ahead and give you a coordinate axes, or coordinate axes for these. But if you need to draw it by hand, just do something to make it, apparent what you're doing. So a graph that I copied over from Desmos. Move this over here. It's going to cover up ours a little bit, but here we'll just go ahead and cover it up. So let's say we want to graph that same point 245 on this one from Desmos. Oops, hold on one second. Where's my brush? Okay, so we're going to do 245 again. It's a little bit easier to see on this. Actually, my graph's in radians, so we'll do 2 pi over 4. Okay, so pi over 4 is going to be this diagonal line right here. Okay, so I'm looking at this one right here, that diagonal line, and you would count out 2 units from the center. So 1, 2 would be our radius. So that would be the point 245. Okay, or 2 pi over 4, since this one is units in radians, but it would be the same point. Let's say that we wanted to do 4, 7 pi over 6. Okay, so we're going to go out 4 units from the center along the line 7 pi over 6. So here's the line 7 pi over 6. It's marked for us. And we're going to go 1, 2, 3, 4 units out from center. And that's going to be our point 4, 7 pi over 6. Okay, so pretty similar to what we were doing with the circles. Okay, the radian measure or the degree measure is the same place on the graph, and then you just count out the radius from the center. Now, one thing that's a little bit different, because everything that we've been doing, there's been a positive radius because we've been setting up triangles. You can also have a negative radius. So let's say we've got like, let's do negative 2 pi over 3. Okay, so we would go 2 pi over 3 is our angle, but the negative 2 here, this kind of plays into the stuff that we just did with the vectors. The negative 2 tells you to go the opposite direction, just like a negative vector goes the opposite direction. So you'd come around to 2 pi over 3. That's, here, let me mark it. That's this diagonal right here. Okay, so there's the 2 pi over 3 line, but we're not going to go 2 out from the center that way. We're going to go 2 out from the center the opposite way. That's going to land us right there. Okay, so instead of going out 2 pi over 3, we're going to go backwards 2 pi over 3. So you're going to go the exact opposite direction, which makes a straight line with it. So what I'm actually following is this right here, going the opposite direction. Okay, so just like with vectors, negative means to go the opposite direction.